This is Bob Capetta, and this lesson is Introduction to Truth Tables. So let's remind ourselves of how these things work. We have a statement P that could either be true or false. So how would not P work then compared to P? If P is true, not P is false. If P is false, not P is true. That's in essence how our negation statement works. Note if we have two separate statements, we have P and we have Q. So what are all the possibilities for P? Well, P could either be true or false. So we'll say true, true, false, false. Q could be true or false. So what are all my possibilities? If P is true, Q could either be true or false. If P is false, Q could either be true or false. So we want to construct a truth table. That's what these things are for P and Q. So P and Q is true only when both items are true. P is true, Q is true, so P and Q is true. P is true, Q is false, so P and Q is false. P is false, Q is true. Again, P and Q is false because they both have to be true. If they're both false, certainly they are both false. So that is our truth table for P and Q. Let's go ahead and construct a truth table for P or Q. Here's P, here's Q. And these first two columns will typically be the same when you're making a truth table with just two cases, P together with Q. P could be true or false. I'm going to need a total of 4 statements. Q can either be true or false. We want to take a look at the truth table for P or Q. What is the truth table for P or Q going to give us? True, true is at least one of them true. Remember, an or statement is true as if at least one of them is true. True, true, certainly at least one of them is true. True, false, at least one of them is true. False, true, at least one of them is true. False, false, no. And remember, or in mathematics means one or the other or both. Or in mathematics means one or the other or both. So, I mean, we can look at various things to try to establish their truth value. So if P is the event, Tallahassee is the capital of Florida. And Q is the event that University of Florida plays football in the Big Ten. There's some things we want to know. We want to know, determine the truth value of the following. First, how about not P? Second, how about P or Q? Third, how about P and Q? And let's do one last one. How about not P or Q? So we want to determine the truth value of these statements. So let's take a look at P and Q. Is P true? Is Q true? So we're going to make a truth table here to try to identify what's happening. P, Tallahassee is the capital of Florida. That is a true statement. Q, University of Florida plays football in the Big Ten. That is a false statement. University of Florida plays football, as I record this video, in the Southeastern Conference. So now what is the truth value for not P? So currently P is a true statement. So not P, what would not P be? Well, if P is true, not P is false. So the truth value for not P is false. How about P or Q? So we have next. P or Q. P or Q is true if one or the other or both is true. P is true or Q is true. Well, P is true, Q is not. Is one or the other or both true? Yes. So that's going to go ahead and get us a true statement. The next thing I'm asking for is P and Q. What is the truth value of P and Q? P and Q is true if both are true at the same time. What is P? P is true. What is Q? Q is false. Are they both true at the same time? Nope. So that is a false. And the last one I have here is not P or Q. Now, when I do these, I like to write them right next to each other. So what was not P? Not P was false. P was true, so not P was false. Q, what was Q? Q, University of Florida plays in the Big Ten. Q was also false. So I'm looking for the truth value of not P or Q. Remember, the not goes with the P. The order of operations tells us that this is the order it's going, not P or Q. That's true if one or the other or both are true. Is one or the other or both true? Not P is false, Q is false. Are one or the other or both true? The answer to that is no, and the result is false. So what are our truth values again? Not P's truth value is false. P or Q's truth value is true. P and Q's truth value is false. Not P or Q's truth value is false. So let's take a look at how we build a larger truth table for a statement like not P or Q. So rather than determining truth values, our goal is going to be to construct a truth table. And we'll look at a few others for sets of 2 items and sets of 3 items. So here are our directions. Construct a truth table for the statement not P or Q. And remember, order of operations. This does not mean not the same as not P or Q. Order of operations are important here. So not P or Q is what we want. We want to create the entire truth table. So how does that work? We've got P, we've got Q. P is true or false. Q is true or false. So these first 2 lines are going to be the same. I need to construct not P. If P is true, not P is false. If P is true, not P is false. If P is false, not P is true. If P is false, not P is true. Well, I have not P here and I have Q there. So not P or Q, one or the other or both has to be true. Not P or Q is one or the other or both true? Yes. Q is true, so that gets a value of true. Not P is false, Q is false. Is one or the other or both true? Nope. That's false. Not P is true, Q is true. Certainly at least one is true. Q is false, but not P is true. One or the other or both true? Yes, it is. So that is our truth table for not P or Q. Now let's take a look at one where the parentheses are a little different. Let's construct a truth table for not P and Q. So how is that process going to work? A truth table for not P and Q. Here's P, here's Q. You get the idea how to get this started. True, true, false, false on P. Q goes true, false, true, false. I'm going to first need to do P and Q. So P and Q will be true if both are true. P and Q true. True, true, both true, yes. True, false, both true, no. False, true, both true, no. False, false, both true, no. So that is my truth table for P and Q. Now I'm going to negate that, not P and Q. Anything that is true becomes a false. Anything that's false becomes a true. True becomes false. False becomes true. False becomes true. False becomes true. So that is our truth table for not P and Q. So you see the process that's involved in developing truth tables for these sorts of statements. Now, what happens if we have 3 statements? Let's take a look at those. So I want to look at P, Q, and R. So we've got P, we've got Q, and we've got R. So we know how to do our table for P with Q, TT, TF, FT, FF. But I'm going to do TT is the first one, right? The second one was TF. The third one was FT. And the last one was FF. And what I'm going to need to do is I'm going to need to double all those. So this is what we had before, TT, TF, FT, FF. Double them. So TT is there twice. TF is there twice. FT is there twice. FF is there twice. And now the third spot just alternates TF. TF, 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 TF. This gets a little tricky to see, so it's probably worthwhile to draw in some horizontal lines just to keep all of these straight. So our first line, TTT, TTF, TFT, TFF, FTT, FTF, FFT, FFF. So those are all 8 cases. When you have 2 letters, you have a total of 4 cases. When you have 3 letters, you have a total of 8 cases. So that is our setup. Now, what's our goal here? We want to construct a truth table for something. How about the following? How about P and Q or not R? That'll be our goal. P and Q or not R. So I'm going to build the P and Q column first. Remember, P and Q is true if both P and Q are true. True, true yields true. True, true yields true. TF, TF, they're not both true. False, true, false, true, they're not both true. False, 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 they're not both true. So P and Q are true in the first 2 because TT yields T, TT yields T. Both P and Q are true. Now, how about not R? How about not R? Currently, our R column is TF, 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 TF. So what will not R be? Not R will be T becomes F, F becomes T, T becomes F, F becomes T, T becomes F, F becomes T, T becomes F, F becomes T. That is the not R column. So think of these as single concepts, as items, as units. And these are linked with an OR. Remember, this is an OR statement. That will be true if one or the other or both are true. So my column, my last column in this truth table, P and Q or not R, what will that be? As long as one or the other or both are true, that gets a true statement. So I see a T here, so that's true. They're both true here. That's good. They're both false. If it's or and they're both false, is at least one of them true? No. Where else are they both false? Anywhere? Here, false, false. So is one or the other true here? No. So the false, false becomes false on an or. Everything else should be true. Oh, here's another false, false. Excuse me, false, false here. So false, true becomes true because it's or. false, true becomes true, false, true becomes true. So P and Q or not R yields this truth table. So let's go ahead and do one more like that. Let's do the following. So the goal is to construct a truth table for P or not Q and R. So we've got to go ahead and build our first three columns, P, Q, R. I like to just skip a line, TT, TF, FT, FF, that's easy to remember, and then double them up, so TT is there twice, TF is there twice, FT is there twice, FF is there twice. And then the third column alternates TF, 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 TF. So we've successfully come up with the first three columns of our truth table. And I do think it is easier to see this if we draw in the horizontal line. So doing this on graph paper might make it a little easier. I need P or not Q. I'm going to recopy the column of P because I like to have them both next to each other. There's P, 4 T's followed by 4 F's. And then how about not Q? If Q is T, not Q is false. If Q is false, not Q is true. Q is true, not Q is false. If Q is false, not Q is true. Now I need P or not Q. So my next column will be P or not Q. Remember, that is one or the other or both are true. And I like to look for the FFs. Wherever I have FFs, it fails an OR. Except it's not an OR. Yes, it is. Wherever I have an FF, it fails an OR. So P or not Q, FF, that's a fail. FF, that's a fail. Everything else has at least one true. There's a true here, there's a true here, there's a couple of them here. There's a true here, there's a true there. Now I need P or not Q and R. So I like to make another copy of the R column. What is the R column? Alternates TF, TF, TF. TF, 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 TF. And then my last line, I link those two together with an and. P or not Q and R. When is an and true? The and is true when both statements are true. Look for TTs. TT, both are true. TT, both are true. TT, both are true. Those are three cases where both are true. Do I have any others where both are true? I don't think so. Make sure that looks like an F, not a T. So there's our truth table for P or not Q and R. So watch your order of operations, use parentheses to make sure that you're carefully indicating which property takes precedence. And be careful, it's easy to miss these. So just take your time, be careful, and best of luck with it.